In the fourth lesson in our engine building series, we're going to debunk the myth that if you want to build your own engines in your home workshop, that you're going to have to drop tens of thousands of dollars on specialist equipment. The reality is nothing could be further from the truth, but there are a couple of caveats that I'm going to add in here. First of all, for the average home enthusiast, I'm going to assume that if you're already working on your own car, you've already got a reasonably well-equipped workshop with just your normal mechanics tool set. I'm talking here about things like a socket set, pry bars, screwdrivers, just the usual equipment that you'd be using to work on your car anyway. So we're going to assume you've already got that and we can set those things aside. One tool that I will add in here though, that you're probably going to include in your normal mechanics tool set, and it's essential for engine building, is a high quality torque wrench. When we're talking up some of the mission critical fasteners inside of the engine, and I'm talking here about things like our connecting rod bolts, getting the torque setting absolutely correct and to the manufacturer's specification is critical to the life of your engine. So make sure that you've got a good quality torque wrench, and if you're inclined to drop it from time to time, then make sure you also get it calibrated, because that is not a great way to ensure the reading of your torque wrench is going to be reliable. The second caveat that I'll add in here is that we're not going to be performing the machining operations on our engine components ourselves, and we've already covered this off in the previous 3 lessons in this series. This is completely unrealistic for the home enthusiast. Not only would machining our own components require hundreds of thousands of dollars worth of equipment, it would also require years of training in order to know how to use it. So these steps we're absolutely leaving to a professional engine machinist, and straight away that strips out a lot of the equipment and expense required to build our own engines. So what are we left with? Well, here I'm going to cover off some of the key elements that you will need to consider. The first of these is when it comes to actually measuring up our clearances inside the engine. These are critical, so we want to absolutely be sure that they are within the manufacturer's specification. Now, we can have our engine machinist do this for us, but I'm a big fan of always checking these things yourself. I believe that the person that is assembling the engine is ultimately responsible for ensuring every clearance inside the engine is exactly where it should be. So how do we do that? Well, there are 2 options available. First, let's look at some more professional equipment for doing this task, and it starts with a micrometer. We'll get this under our overhead. Micrometers, nothing particularly unusual about these. We're going to need a set of these micrometers, and they allow us to make very precise measurements of the outside diameter of our crankshaft journals if we're measuring our bearing clearances, or alternatively of the piston skirt if we want to measure our piston to cylinder wall clearance. Now, there is an expense in buying a set of micrometers, and we are going to need a set because this is an imperial micrometer. These only work across a range of 1 inch. So if we flip this over, we will see that this particular micrometer here is capable of measuring between 1 and 2 inches. And obviously there are a range of sizes of our crankshaft journals and pistons, so it's not a one size fits all exercise. Now, when it comes to actually buying micrometers, there are a wide variety of different quality and price points that you can select from. The one that I've actually got in front of me is a relatively cheap Chinese micrometer set, and this was purchased as a full set for around about $400 US. Now, I know what you're thinking. I know some of the components that we've seen for the automotive industry coming out of China have been of questionable quality, and I am always very cautious when I'm buying something that isn't name brand for the likes of maybe Mitutoyo, for example. However, double checking these against our own Mitutoyo micrometer, they actually check out and they do a really good job. They're accurate, they are repeatable, and they are well priced. It's not just the micrometer you're going to need though. While yes, this will allow you to check the diameter of your crankshaft journal, and we can then compare that to the factory workshop manual and make sure it's within range. If we want to check our bearing clearances, we're really going to also want to team that up with a dial bore gauge like this. Now, the dial bore gauge, if we get this under our overhead camera, we can see we've got a dial indicator at the end, and we've got a little adjustable extension here. We can change the length of these to suit whatever bore diameter we want to measure, and we've got a little plunger here. As that moves, we can see that it moves the dial at the end of the dial indicator. So the idea behind this is that once we've used our micrometer to check our outside diameter of our crankshaft journal, we can then use our dial bore gauge, and we're going to zero that between the two anvils of our micrometer. So what this does, it doesn't actually give us a specific measurement on the likes of our bearing journal itself. What it does is it gives us a comparison. We've zeroed it on the outside diameter of the crankshaft journal. Then we can insert the dial bore gauge into the journal that we want to check, be that the main journal in the engine block or the big end journal of the connecting rod. And the dial indicator will then show us the difference between the outside diameter of the crankshaft journal and the inside diameter of our bearing journal. This, of course, is our oil clearance. Now, this is a great tool and it is very, very accurate. But there are a couple of elements that we do need to consider here. First of all, both of those pieces of equipment have a reasonable price point to them. I've already talked about the micrometer, a dial bore gauge. Depending on your brand, you're probably going to be looking somewhere between maybe 100 and maybe 500 US dollars. So again, it's going to add up. The bigger aspect here, though, is that in order to get reliable and accurate results with both of those pieces of equipment, there is a little bit of knowledge that comes along with that. So if you don't know how to use those pieces of equipment, you're very likely to get unreliable results. And no one wants to spend good money on precision measuring equipment only to end up with questionable results. The other technique that is absolutely viable, very, very cheap and very easy to use is Plastigauge. Plastigauge or Flexigauge. I've got a pack of it here. Comes in different colors, and essentially what this is a flexible wax strip. What we do is we cut the wax strip, we lay it across the crankshaft journal where we want to check our clearance. We dummy assemble the engine, torque the main bearing caps or the connecting rod cap into place. Then we simply undo everything, strip it apart again, and what happens is that wax strip is going to be crushed flat. And the less clearance we have, the tighter that clearance is, the wider our Plastigauge strip is going to be crushed. What we then do is when we strip the components apart, we compare the scale on our Plastigauge pack to the width of our Plastigauge strip on the crankshaft journal, and that will give us our clearance. Now, Plastigauge is a product that causes some controversy. There's a lot of people, engine builders and enthusiasts alike, who think that Plastigauge is of absolutely no value. I, on the other hand, completely disagree. Most of the instances where Plastigauge is giving questionable results is because it has been used incorrectly. And just like any tool, just like the tools we've already looked at, this does require an understanding of what it is and how to use it properly. And the essential element that's so often overlooked here is that when we use Plastigauge to check our clearances, it is absolutely critical that the engine is assembled dry with absolutely no lubricant on the crankshaft journals or the bearings. If we add lubricant on the other hand, which would be normal when we're assembling the engine, this will affect the reading that our Plastigauge gives us, and it's going to essentially be of no value to us. Now, obviously, if we are going to be doing a dry assembly like this, it's also really critical that the crankshaft is not moved or rotated while we're going through this process. So it's a little bit to understand, but it is really, really easy to use. One of my favorite elements with Plastigauge, though, is that at a glance, it's very, very easy to visually see if there's any taper on a journal, because that Plastigauge will stretch the full width of the crankshaft journal. Now, while using a dial bore gauge and a micrometer, we can also check for taper. It is a lot more fussy and a lot more tricky to actually see that with those particular pieces of equipment. And you will find that even professional engine builders will keep a few packs of Plastigauge on hand, and they can be used as a bit of a sanity check just to ensure that everything we saw with the dial bore gauge and the micrometer stacks up when we do a quick check with our Plastigauge. Next up, let's talk briefly about balancing equipment, and we've already talked about this and seen it in action in one of our previous lessons. I've got our Rod Balancing Fixture here along with a set of our digital scales. Balancing our own components, particularly if we're just looking at the pistons, is really, really easy. All we really need for this is a decent, reliable set of scales, and we can spend a lot of money on scales, but I've actually found that that's not always going to be necessary either. The scales that I've got here are really, really cheap. They're under 100 US dollars, depending where you get them from. You'll probably be able to find them for somewhere around about 50 to 60 US dollars. Now, That does sound like a questionable amount for a precision set of scales. However, we're not actually that interested specifically in how accurate the measurement is. So what I mean here is if the scales tell us that our piston weighs 300 grams and in reality, on an absolutely high-level precision set of scales, it weighs 305 grams. That for us is not going to be the end of the world. The more important element, rather than accuracy, is repeatability. And by this, what I mean is that the scales need to read the same if we put the piston back and forth on the scales without making any changes to it. So if we sample it 5 times, we really want exactly the same result 5 times. This way, we know that we can trust the set of scales. The other element that's important here is the resolution of the scales. I'm measuring in grams here, and we need to be able to measure down to 1/10 of a gram. Let's have a quick look at this repeatability. So we'll take our JE forged piston here, and we'll gently drop that down onto our scales, and we'll allow our scales to stabilize. We've got 331.9 grams. We'll remove the piston, making sure that it comes back to 0, and then we'll drop that piston gently back down onto our scales. And we can see we've got exactly the same 331.9 grams. So it's really easy to do a little bit of a sanity check with a set of scales like this and just ensure we are getting that repeatability. Now, obviously, we'd like the scales to be accurate as well, but that repeatability is much, much more important when it comes to balancing the components that we are balancing in the home workshop. Let's get our scales out of the way here, and we'll talk just briefly about our Rod Balancing Fixture. Now, this is a job that you can absolutely leave to your machinist, because a fixture like this is going to set you back somewhere in the region of maybe $100 to $200 US. It is essential to have a fixture to balance the connecting rods, because this allows us to balance the big end of the connecting rod independent of the small end. When we're balancing the connecting rod, it's not just a case of balancing the overall weight of the connecting rod. The other element to consider if you are in the market for a Rod balancing fixture is that with the ones that I've used, I've seen a large variation in the repeatability or consistency that I get with the results. It's really important to use a quality one, particularly with this unit. We've got roller bearings fitted to it, which takes out a lot of the friction in the mechanism, and this helps ensure consistency and repeatability. Even that being said, it is still a fussy job in order to get repeatability, and that, again, just like we looked at with our scales, is essential in order to be able to do a quality job of balancing our connecting rods. Next up, I'm going to cover one of the absolute essential must-haves, and that is a piston ring grinder. Now, when we are building factory engines using factory components, the rings come essentially pre-gapped, and while we will need to check and make sure that the ring end gap meets the manufacturer's specification, that will typically be the case, and they won't need to be filed or adjusted. On the other hand, in the aftermarket piston world, we're more likely to end up with what is called a file fit piston ring set. These are purposely delivered oversized, and if we simply installed them without adjusting the end gap, we would almost certainly have them butt together in operation, causing a catastrophic engine failure. Because these are oversized, it allows the engine builder to grind the end of the ring in order to achieve their desired ring end gap. And this can be adjusted depending on the fuel the engine's running on, whether it's naturally aspirated, turbocharged, supercharged, or maybe running nitrous, and also depending on the application. In other words, whether it's a street car, a drag car, or an endurance race car. But we need a way of adjusting that ring end gap, and that is with a product like this, our ring file. So with our ring file here, this is a relatively cost-effective option. This one here, you'll be able to pick up something that is of a similar construction for probably around about $40 to $60 US. So they are quite cheap. And as we can see here, we've got a bed that our ring sits on. We've got our grinding wheel, and our grinding wheel is simply rotated by hand. Not very difficult to use, but it is quite difficult to get consistency and accuracy across our entire ring set when we're using a hand file like this. Because it's not just the ring end gap we're trying to achieve, it's also making sure that the two ends of the ring are parallel to each other. That is also really important. So this is a great place to start, and I've built dozens of engines using one of these. If you're only going to build one or two, this is absolutely what I'd recommend. And again, cost effective. On the other hand, if you are considering building multiple engines, I would highly recommend you consider looking at an electric ring file. Yes, these are going to be more money. You're probably going to be looking at a minimum of about $150 up to $300, $400, $500 depending on the brand and quality. Benefits with the electric ring file is that they allow you to set the bore diameter to ensure the ring end gaps are going to be parallel, and normally they will also have a dial indicator fitted, which makes it much easier to be accurate in how much material you are removing. Benefit of this is speed and consistency. You're going to be able to gap all of your rings faster, and you're going to be able to make sure that all of your ring end gaps are the same across your entire set, be there 8 pistons, 6, 4, it doesn't matter. So great place to start with a manual ring file, but if you are going to be building engines, particularly a number of them, then the electric ring file probably is going to end up saving you money in the long run. Let's get our ring file out of the way here, and the last tool that I'm going to show you that will be an essential is a ring compressor. I'll get this one under our overhead, and this is a relatively common and relatively affordable style of ring compressor. It is a sleeve that goes over the top of the piston and ring. And if we get our piston back in here, the reason we need this is because our rings actually expand out from the piston. So we can't fit the piston into the bore like this. What we need to do is compress those rings into their ring grooves. But in order to do that, we need the ring compressor. The ring compressor simply slides over the top of the piston, and then we can insert this key into the ring compressor, and then we can turn that key and that will compress the rings. We then insert the skirt of the piston into the bore, and we can gently tap the piston down through the ring compressor and into the bore. Now, these work really well, but this style of ring compressor does need a little bit of care in operation. It is very difficult if you're not taking particular care for a ring to pop out between the underside of the ring compressor and the top of the bore. And if you don't notice that and you're continuing to tap the piston down into the bore, it's very easy to damage or even break a ring. That's also likely to end up scoring your freshly honed bore. So these are a great place to start, probably in the region of about $50 to $80 for one of these ring compressors. But as I mentioned, they do need to be treated with a little bit of care. Nothing wrong with that. They can get great results. However, my personal preference is a tapered ring compressor like this one here. This one's from ARP, but they're available from a range of manufacturers. And as the name implies, it's a taper, which means that the top of the ring compressor is larger than the bottom. So what we can do with that is we'll drop our piston and our connecting rod assembly down into the top of the ring compressor, get it lined up. Once it protrudes a little bit, we end up with a bit of the skirt protruding from the base of the ring compressor. We can now insert that into the top of our bore. And these are really easy. With just some pressure from our thumbs, we'll be able to push that piston down through the ring compressor and into the bore. Now, the benefit of these ring compressors is that it is almost impossible to damage a ring or damage a bore. They're just not really that hard on the equipment, and it's very difficult to do anything with one that could result in damage. The downside with them, however, is twofold. First of all, these are reasonably expensive depending on the bore size that you're going for, maybe somewhere in the region of $40 to $100. And the other element is, as we can see, this one is marked with 86.5 millimeters. These will only work with one single bore size. Not a big deal necessarily if you are just building one type of engine, but if you're trying to build a range of different engines, you're going to need one for each bore size you're working on, and clearly that can start adding up quite quickly versus the generic universal compressor that we showed you before. These are obviously going to work with absolutely any bore size, so a little bit more flexible and a cost saving there. But it only takes damaging one ring, one piston, or one bore, or maybe all of the above, to quickly make the tapered style ring compressor seem like a very cheap investment. So this brings us to the end of our fourth lesson, and if you've enjoyed what you've seen so far, maybe it's piqued your interest and maybe you want to consider building your own engines, then we do have an engine building starter package that's going to be perfect for you. I'm just going to clear everything off our workbench here, bring in my laptop, and I'll go over what this package is and exactly how it works. Alright, so our engine building starter package includes essentially everything you're going to need in order to take you from zero previous experience building engines through to having the confidence and the knowledge to start assembling your own engines for your own project car. And I'll cover off what is included in each course. We start with our engine building fundamentals course, which is valued at $129 US. As its name implies, this is a fundamentals course, so there is no need for any previous knowledge. It'd be helpful if you've maybe spun a spanner once or twice, but you absolutely don't need to have built any engines. You don't need to have even stripped an engine or seen inside one. We start with understanding the four-stroke principle and all of the components inside of an engine and how they work. You'll learn about the clearances and the tolerances inside your engine and how you may need to adjust these tolerances and clearances if, for example, you're building an engine that's going to make 2 or maybe 3 times the power of the factory engine, and maybe you're going to extend the rev limit by another 1000 RPM. You'll also learn all of the typical machining operations required for a performance engine build, and this is really important because, as we've already discussed, we're not doing the machining work ourselves, so this knowledge is critical so that you're going to be able to talk the same language as your engine machinist, making sure that you get the right results, the right machining operations, without wasting time and money on other things that really aren't required for your particular engine build. Moving on, we then have our practical engine building course, which is valued at $199 US. This builds on the knowledge taught in the fundamentals course, and this time we're going to get our hands dirty actually building our own engine. It's important to mention that this course, as well as the fundamentals course, is generic. So it doesn't matter if you're working on perhaps a pushrod, overhead valve V8, maybe an LS for example, maybe a twin cam 4G63, maybe a quad cam V12, or just about anything in between. The courses are 100% applicable. We know that when you get all of your parts back from the machinist, it can be a bit daunting knowing what to do first and what order to progress in. So what we've done is we've broken the entire engine building process down into the HPA 10-step process. By doing this, each of the individual steps is relatively quick and easy to complete, and in no time you've got to the end, you've got a completely assembled engine, and you're going to have the confidence that all of the parts you've chosen for that build are going to be suitable for your power aims. You're going to know that all of the clearances and tolerances inside the engine are exactly where they should be. And this is all going to add up to mean that when it comes time to start the engine for the first time, it's going to run properly, it's going to deliver great power, great torque, and most importantly, great reliability. This particular course also has a second part, which is our library of worked examples. And this is an informal walkthrough of that 10-step process. You can watch each of those steps from start to finish in real time. And in this library of worked examples, we vary the type of engine that we're working on so that you can get experience on a wide range of different platforms. We also add to this worked example library from time to time. Once you own this course, you get free access to any future worked examples at no cost. So this course is going to continue to grow with you. Next up, we're also including our How to Degree a Cam course valued at $49 US, and adding a performance cam or camshafts to any engine build is probably one of the more common ways of extracting more performance, and absolutely it can be a great way of getting more power and torque out of your engine. However, in order to do that, you are going to have to make sure that the camshaft is installed and degreed accurately to the cam manufacturer's specification. Also important with bigger camshaft profiles to ensure that you've got sufficient piston to valve clearance and basically nothing's going to collide and result in a catastrophic engine failure. In this course, you'll learn the different types of valve train and valve actuation. You'll learn all of the terminology associated with camshaft operation so that you can read and decipher a camshaft specification card. Then you'll learn how to actually install and degree your camshaft, irrespective if you're dealing with a pushrod, overhead valve engine, or a quad cam V12. We also include a simple to follow 6-step process that you can apply to degreeing your own cam. And just like the practical engine building course, we also include a library of worked examples where you can follow through that process from start to finish. Lastly, we are also including 2 full years, 24 months of gold membership, which is valued at $456 US. That gold membership gives you access to our private members only forum, and this is the best place to get trustworthy and reliable answers to your specific engine building questions. Our gold members also get access to our live webinars where we'll cover a topic on engine building, engine tuning, wiring, 3D modeling in CAD, and a variety of other elements that we cover inside of our courses. As a gold member, you'll also be able to review our existing archive of webinars. We've got over 300 hours of existing content in that archive. It is an absolute gold mine and one of the quickest ways to advance your knowledge on a massive range of performance automotive topics. So the entire package is valued at $833 US. But we're making it available for just $299 US. This is the fastest and most cost-effective way to get you up to speed learning to build performance engines. We know that even $299 US though is still a chunk of cash to come up with in one hit, and we want to make this package as affordable as we can so that we can help as many people out there learn the skills of performance engine building. For this reason, we also offer a payment plan option, and you can break that purchase down into 8 individual weekly payments of just over $37 US a week. If you use our payment plan, you still get access to all of that course material the second your first payment has processed. We also know that when it comes to purchasing online education like this, it can be a bit daunting. Obviously, you don't know exactly what you're going to be getting until you've purchased, and we want you to be able to purchase with complete confidence and zero risk, which is why we offer a 60-day, no questions asked money-back guarantee. So if you purchase and for any reason at all decide it's not quite right for you, maybe it's not what you expected, no problem. Let us know, we'll give you a full refund of the purchase price. If you do have any questions, you can ask below and you will find a link that you can click to make your purchase.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.